topic or second way of putting the things, that is unit 3. So we call this one as a data preprocess. So when we are talking about data preprocessing, before I work to the data, I need to make pre-processing applications, that is cleaning, integration, data reduction, transformation, and discretization. So why we need to do all these things? Because data is going to be impure. Data is going to be impure, and that data needs to be pure. So we need to work on pre-processing techniques. We need to work on pre-processing techniques. So this main motto or main intention why we are going to use pre-processing. So data is computed. Yeah, error data has to be removed before we need to do some analytics, some over the existing data. If we are not going to do those things, definitely errors will come and a good analysis application will not come out. We are going to do pre-processing as a so coming to the pre-processing, why we do with this pre-processing was that data in the real world is to be so then the statistics are going to be shown. One, we are going to call it as incomplete data. It doesn't. The reason why there is no quality in the data. This was the same. Okay. Now, what makes the data to be impure and what will be the characteristics so that data can be pre-processed means the very first one was incompleteness. The very first one was incomplete. So when we are going to call it as an incomplete, so I will ask blood group. I will ask group as a column, as a field name. So at time of admission, you don't know you are about to take the ID card. In that ID card, there will be a column called as blood group, and you don't know your blood group. So obviously, you will tell the officer, I don't know my blood group. So he can't put A positive or B some. He can't put some random values into it. So what he will do is he will just leave the column and go to the next field. So that group should have a value, but that is not. So what it means is we call that one as the first word called as an incomplete data. So when I do some aggregation operations, etc., if data is incomplete means definitely it is going to affect the average value. So first one we were telling that one we are going to call here as
Sir,
yeah. Tell
Screen
me.
is not shared.
Screen is not shared. I am in screen
So
sharing
now,
mode. Screen, I think it is sharing because
yes,
the red boy
yes.
it is out. Right? So we are going to call it as an incomplete data. So incomplete data, yes, I am asking about some marks. So I say subject 1, subject 2, subject 3, subject 4 and subject 5. So it is 100 by 100, maximum is 100. So it is 90, I don't know, and then I'm going to give it as some 70. So if I'm going to compute the mean or if I'm going to compute the aggregate, so obviously it is going to say 265 by 5, which answer is wrong. But if it is what we call it as an incomplete, but you are going to compute the mean by number of subjects. So as these two values were not there, you are not able to give an accurate answer, which you are going to say that word as an incomplete. Going to say that word as an incomplete. So this is the first way. What happens if we are going to give this as an incomplete? Next one, noisy data. So in noisy data, it is containing a lot of errors or it is going to contain a lot of outliers. So when we are going to say it is an outlier, when we are going to say it is an outlier, so the thing was, it is not having normal period, not having any normal period. Classroom, classroom. So it is not going to have any normal behavior. We are going to use the word as an abnormal. So I just quoted you an example. So I say we have 65% to 100% as I can say it is 75% to is going to be a mandatory. So obviously this is not me. So we can say it is an abnormal behavior. So why are we going to call this an abnormal behavior? Because we have given this a range between 75 to 100. So people are going to meet this range and that's why they are in group. But they are not meeting this criteria. So such people, we are going to call them as an abnormality. So identifying such type of errors, identifying such type of abnormalities, we will be calling it as an outliers. And this outliers, we are going to say they are going to contain a error data. They are going to have some error data. So this is noisy. The next thing was what we are going to call here as an inconsistency. The next thing was inconsistency data. So when we talk about inconsistency, when I talk about inconsistency, the file if I am going to have A, you should also have the A. That means both source and both the destination should have items. So suppose that if I am going to write SVECW, then I am going to write engineering college. Some other girl will write Sri Vishnu Engineering College. So now you can see three type of acronyms are given to a same name. Which one is correct? So obviously database will save only one entity. Now we are going to give three different names for a unique item. Obviously it is dealing with an inconsistency problem. So the naming conversions, when we are going to make a retrieval over the database, some item should be constant. So I am going to write prof as a professor. So some people will write professor. So in this way, one has a habit of writing prof dot, another having a name to write it as professor complete. So both are giving the same information, but the naming conversions are going to dispense where we are going to say that word as an inconsistent. So if the real world data is having inconsistency, if the real world data is going to have some noisy data or an inconsistent data, obviously data is impure. Data is going to be impure. If there is an impure decision, means now you need to pre-process the data. We need to pre-process the data and then we can make the data as pure. We need to make the data as pure. So if we are going to make the data as pure, then what's the advantages means that we will be getting the quality decisions. We will be getting a good decisions, and that is purely based on the data which is inside a data warehouse. So if data is not stored correctly, data is not stored properly, obviously it leads to misleading results. If data is going to be stored correctly, yeah, it is fine, we will be getting a good answers. So next one was where we are going to apply the data pre-processing content. So mostly data pre-processing techniques are going to be applied over multi-dimensional model. They will be applied about multi-dimensional model. So this multi-dimensional model, we are going to call it as a cube, and this one, it is going to be applied over data warehouse. So if I am going to talk about a normal database management, normal relational database management system, SQL or MySQL, all this, they are going to have two-dimensional data. They will be showing only two-dimensional data, so that it is going to represent in rows and columns. But when we are going to talk about a data warehouse, it will be implicitly known with three-dimensional. So here we will be having x-axis and y-axis. At this point of time, it is going to project with the z-axis also. So this is where we are going to observe as a part in a data warehouse. So what will be some of the operations which will be taken up as part of a cube means we will call it as slice, we will call it as dice, we will call it as roll up, we will call it as roll down, we will call it as drill up and drill down. So data will be plotted in hierarchies. Data will be implicitly known or data will be moved into different hierarchies, and thereby they are going to be assigned in form of a queue. So this is what the representing the things in Q. So I will just explain this to you with a simple example. Assume that there is a sales data warehouse. There is a sales data warehouse where they are going to write Jan. They're going to write these options. We're going to say sales data warehouse. So in this sales data warehouse, we have from April, May, June, July, August, September, October, November, December, Jan, Feb, and March. So now, according to the business, we have financial year. So you'll be hearing in new subjects, etc. So 2022, 23 budget, so etc. We say it is a financial year. So our financial year will start April and will end at March. It starts at 1st March 31st. So now every 3 months we will assume it as a quarter. Every 3 months we will assume it as a quarter. So Q1, Q2, Q3 and Q4. So we will represent the 3 months average, the 3 months aggregate, April, May, June, July, August, September. So 3 months aggregate what we are going to push, they will be represented as a quarter. So I will say sales of quarter 1 is some 1,000. Sales of quarter 2 is of 2,000. Sales of quarter 3 is 3,000. And sales of 4 is 4,000. So now if I am going to say for the financial year 2022 to 23, now if I am going to get the total sales, so obviously I will be writing it as some 10,000. So this operation we are going to call as roll up. We will be calling that item as a roll up. If I am going to go move this Q1, Q2, Q3, Q4 separate, if I am going to represent the sales operation separately, Q1, Q2, Q3, Q4, then I will be calling it as roll down. Similarly, the equivalent words as mentioned, that is drill down and driller. So these will be the 2 words which we are going to project at this case. So a part of the quarter, so Q1, Q2, Q3, Q4, so this entire segment we are going to call here as a dice. Now I will pick up one subset. Now I am going to pick up one subset. We will be calling it as a slice. Now we are going to pick up one part. So that part we are going to call it as a slice. So what we have taken at this time was, we were talking about a 3-dimensional model. In this 3-dimensional model, it is practiced in a data warehouse, and especially 3-dimensional model is going to be called as a cube. The operations will be slicing, dicing, roll down, roll up, drill down, drill down. So these are what the primitive items in this multi-dimensional model. Fine. We were aware now multi-dimensional view, it is going to be a 3-dimensional view. It has x-axis, y-axis and z-axis. So these we call it as a 3-dimensional view, and the best way was we are going to represent the data warehouse data. That too we are going to represent it in cube format. We are going to represent the data in cube format. So this is the primary intention what I was talking here. So it is having x-axis, y-axis and z-axis. and it takes up a cube and the operations will be slicing, dicing, roll down, roll up. So these will be the operations. Fine. The next thing, what will be the characteristics of those items? First thing, it is accurate. So accurate in sense what the belief, what the mining is going to tell, the appropriate results, what it is going to get will be 100% correct. We are going to call it as an accurate. Next one, the amplification what we are going to derive, that amplification will be definitely a complete item. It will not be a partial item, it will be a complete item. Third thing, it is going to be totally a consistent value. So the naming conversions, etc., are migrated. A uniform format was taken up. So all these are going to be some of the value additions or the accessibility points where this multidimensional data is going to be projected. So let us look into the words in detail. So when we are going to talk about an accurateness, we mentioned the data should be correct or wrong, accurate or right. If you want to say that it is positive, yeah, you give positive, that should be correct. If you want to give the result as a negative, yes, you give a negative result, but giving negative result should be correct. So that is where the accuracy is to be maintained. So if the record is unavailable, if the record is not projected, obviously this completeness property is going to be missed and that has to be highlighted. So at any point of time, even before or after, at any point of time you access the database should be certain. Suppose if I am going to have 5,000 rupees in my account today, and tomorrow if I am not drawing any amount, the same 5,000 also should be there. So yesterday I have 5,000 in my account. I didn't use for any transactions. I didn't do any shopping, etc. So obviously 5,000 should be there. Today if I want to open my account and see my ATM card, again the same money is going to be there. So obviously before transaction and after transaction, so I have the same amount. So they are going to say that is there, it should affect it, it should not neglect both ends, then we say it is consistent. Otherwise, we are going to call that property as an inconsistent. The next thing was timeliness. So at any point of time, the database should be accessible to you. So at any point of time, the servers should not go down. So for example, you can open any type of website, a banking website or etc. You can round the clock 24 hours and at any point of time you can do some transactions. So obviously what it shows, 24 hours, 365 days, the database is open to you and it is access to you. If such a thing is violated, obviously your database is not updated, it is not timely. If it is working with you, yes, it is true. So recently in the news we have heard some 3 hours or 6 hours WhatsApp and the Facebook were down. So the database, there was some issue in the database. Obviously there are some inconsistencies problem raised, some updation operations happened in WhatsApp and Facebook. So that's why around 6 hours the data was not available. So the property of timeliness was not met at that 6 hours. So people doing business on WhatsApp, people doing business on Facebook, so obviously there will be a tremendous loss. So that is where data quality has to be met for them. So next thing was the believability, the evidence, the fact what we are going to show, yeah, that should be true. So if it is not meeting it, again the data inconsistency comes, again the pre-processing, missing values, inaccurate, all these terms will be taken up. And whatever insights we are going to give, those insights should be able to communicate to the end user. If I'm going to represent the things in statistics, p-value is greater than 0.5. My manager will not be able to understand what is p-value, what they should have to take if it is 0.5 greater than 0.5. You have to tell that as the statistics value is given 0.5, the error is less than this much, the error is greater than this much. So error is more than 95% range, so you should not take that decision. If the error is less than 0.5%, you are accepting the null hypothesis. Okay, 0.5 error is inevitable, you can accept it. So the decision was taken is correct. So in this way, the end user should understand the quality decision what we are making it is. So we talked about the first word is pre-processing. Then we talked what are the factors which are making the things as dirty, that is inconsistent, noisy, and incompleteness. So these are affecting the quality decisions. Later on, we talked about a multidimensional view. That is, we mentioned the data warehouse content will be represented in a cube with X, Y, and Z, where dicing, slicing, drill down, drill up operations can be applied over it. And what will be the properties of a good data in a multidimensional means they should satisfy with accuracy, the completeness, the consistency, the timeliness, the interoperability, and the accessibility options. Next comes an interesting word, the way of representing the data mining forms. So here you will be able to understand what are the different forms of data pre-processing. One, what we are going to call it as a data cleaning. So you can understand a silly example here. There was a some box where it is impure, it is dirty, and that it is applied with some soap and soda, etc. Obviously, it went clean. Means here we are going to have noisy data, here we are going to have inconsistent data, or we are going to have incomplete data. So this has to be pre-processed. This has to be processed. Therefore, it's going to be called as impure data, and this impure data should be converted to pure data. So how we are going to do it? We are going to get it called as a pre-processing. So obviously the properties as mentioned earlier, it satisfies accuracy, it satisfies consistency, it satisfies completeness, it satisfies timeliness, it should have believability and interoperability. All these features, they are going to be implemented with cleaning, integration, transformation, and reduction. Therefore, the noisy data will be converted to pure data. So this is the first form representing the items. Next one, data integration. So assume that we have different data marts. So data marts, we will be say they are partial databases. One, it is representing flat files. So flat files, it is meant with the comma separated value, and it is a two-dimensional data. Next one, the things it is going to be in multi-dimensional model where data is going to be represented in cube format. The third thing we have to have management system dimensional data which is done in rows and columns. So this comma separated value, or it is going to be some text file, some data files, etc. So what we need to get is we need to take A, we need to get B, we need to get C, and all of them we put together. Obviously, it has to be brought to the as a data warehouse. So data integration gets data from multiple sources. So what will be the multiple sources means? One, it can be comma separated value. Two, it can be some else. Three, it can which is represented in a cubic, and 4 will be some database management system. So all these 4 are going to put together and then we are going to call it as a data warehouse. So data, we will be getting data from multiple. So we have into the integration means I can say language. So the mother tongue is Hindi, mother tongue is Tamil, and mother tongue is Urdu. So now for all these I need to teach a class. So I'm going to have of 60 students, class of 60 students, and their mother tongue, Telugu mother tongue is Hindi, mother tongue is Tamil, mother tongue is Urdu, etc. So they speak in their regional language, but now I am using an English language, a common platform where this language will reach us to their nativity. So obviously I am going to integrate them the class of 60 students to one uniform language. So there the part we are going to call it as a data integration. So in cloud, one type of way of organizing data will happen. In CSV, one type of data organization will happen. In data marts, one type of data organization will happen. In this way, we will be having sources organizing the data into different formats. But now we need to get a unified format. We need to get a common platform so that all the data will be converted and used uniquely. So this will be the advantage of using the data integrity item. Next word. The next word what we are going to pose here was data transformation. The next word what we are going to bring here was data transformation. So you can see an example 0.2, minus 2, 0.32, 100, 59 and 48. So this was the scale of representing the things. So we have the data as 2, we have the data as 32, as 100, we have data as 59 and we have data as 48. So we are going to have these elements. Now we need to bring the word called as data transformation. So data transformation is a unique scale to all numeric values. For all the numeric values, we need to bring a unified way, a unique format. So how is this possible means? Now this is minus 2. Now you are going to say minus 2 divided by 100. So you will be getting minus 0.2. Similarly, 32 divided by 100, you say 0.32. 100 by 100. You are going to say 100 by 100, again you will be getting 1. Similarly, by 100 by 100, 0.59, 0.48. Now what happens was, we have positive integers and we have negative integers. We have positive integers and we have negative integers. Maybe we will have integer data or we will be having the, so is to be transferred to same data type, but to numeric. So if this is a case what we are not, we will assume this word as a data transformation. So in data transformation, we have a raw data. That raw data is going to be in its own form. It may be positive integers, negative integers, with but all of them are going to scale. The scale I'm going to bring uniformity, that it should use a value called as a. So as it is going to numerate, now all at a uniform slab, that is divided by 100, and all the values will be in that range. We will assume that part here as a data transformation. The next thing was data reduction. The next thing was data reduction. Here we are going to have tuple 1, tuple 2, up to tuple 2000s. Then we are going to have attribute 1, attribute 2, attribute 3, and attribute 126. Now the data set size. Now the data set size, what we can have to do is into 126. 12,000 into 126, it is going to be a very, very vast database. So it becomes a huge axis matrix where data has to be represented in our laptop with a 4 GB RAM or 8 GB RAM. It will be very, very difficult to do machine learning analysis over it. So what will be the solution was, we need to go with a technique called as data reduction. We need to move with a technique called as a data reduction. In data reduction, as per query requirement, only subset of rows or columns are considered. So obviously I am going to have 2000. Now it is reduced to 456. Here I am going to have 126. It is reduced to 150. So from the superset, I am going to have a subset that we are going to do some analysis. We call that property as data reduction. So in data reduction, we have a superset, and that superset will be reduced to subset. So as per query analysis or requirement. So I am going to have a table which it is going to show up with some attribute 1, attribute 2, attribute 100. Then I am going to have tuple 1, tuple 2, then tuple 100. Now what is the size of this data set? The size of a data set is equals to number of rows into number of columns. Number of rows into number of columns, that is 100 by 100. Now I am going to reduce as per requirement query. So what we call this technique as optimization. We are going to call this word as an optimization. So when we are going to use this word called as an optimization, what happens was that we will be having only a subset. We will be having partial items. We will be having partial. Here we are going to have a complete items. So this was the difference. At one case, we are going to have partial items, and another case, we do have a complete items. So we will be having some A1, A2, A3, and this is some T1 and T2. So now the data size is 2 into 3. So obviously 6 is going to be the size. So this is how you are going to vary from 10,000 requirement to 6. So a huge volume of reduction where we are going to call the concept as a data reduction. So what we have made at this point of time was we were talking about the different forms of data processing, which is including integration. So these are the most important features of data processing. Every feature has statistical qualifications to do it. Just how you can make it. It is a technique. It is a statistical technique. It will be discussed in due course of time within 3 or 4 classes. So data reduction has some techniques. So those techniques we are going to apply from the main set, from the superset. We are going to have a partial item where we call that simplification as a data reduction. So this is what we have taken up, the different forms of pre-processing. After that, now we were talking about different techniques or different tasks. Different techniques or different tasks which are going to be part of a data pre-processing. One, data cleaning. So in data cleaning, we have fill the missing values, smoothing the noisy data, identifying or removing the outliers, followed by resolving the inconsistency problems. So the 4 techniques, the 4 tasks in data mining, it is fill in the missing values, smooth the noisy data, identify and remove the outliers, and resolve inconsistency. So how we are going to do, we will discuss now. Similarly, integration. We will get data from multiple sources, that is from cubes, flat files, and databases, all are put together. Similarly, data reduction. So we are working on a word called as dimension reduction, where in this dimension reduction, 100 by 10,000 is going to be the size of a dimension, which we have reduced to 6. So obviously, it is what a technique called as a dimension reduction. Similarly, we use WinRAR or WinZip file. So WinRAR, WinZip file, we are going to use this software called as WIN WinZip, or we will use the software called as WinRAR. So why we are going to say we are going to reduce, or we are going to compress the file size. So for that we are going to use this techniques. So data compression. So WinZip and WinRAR are going to use the size. How a compression is done, we will discuss. Now, the other word, what we are going to call it is data transformation. So data transformation has 2 techniques. One we call it as normalization, another we call it as a concept hierarchy. So these 2 techniques we have discussed. A quick recap of that, what is normalization. So we have taken up the raw data here, that is -2, that is -2, 382, 100, 59, 48, and they are positive integers, negative integers, they can be integers, they can be float. All of them, they are going to be put in a uniform scale, that is divided by 100 and represent the data. We call that is data transformation. And the second word what we are pinning now was concept hierarchy. Concept hierarchy. In our last class, we have discussed on few examples of concept hierarchy. I will represent it again. So we call it as professor, then we call it as some associate professor, then we are going to call it as a assistant professor. So you have a student, and then again the student, we do have some CRs and HRs, etc. So in the same way, we are going to have this leadership content as professor, associate professor, and an assistant professor.
Another example, there is a 10 rupees postcard envelope or an envelope. So you write your address here. So you write 2 and then you are going to put the columns. So it is name followed by house number followed by street followed by city followed by pin code and followed by state followed by country. So now you do have this 2, 3, 4, 5, 6 and 7. So these 7 we are going to call here as a levels, and putting these levels, distributing the data into different levels, we are going to call that item as a concept hierarchy. So I am going to have 180 students. So 501 to 565, I call it as CSEA. So this is level 1. Then I am going to say 566 to 5C9. This is going to be one level CSCB. So we divide this into different set of groups one by one. We say that concept here as a data transformation and data discretization. So what is discretization here is professor is 1 grade, associate professor is 1 grade, assistant professor is 1 grade, CRC is 1 grade, general students are 1 grade. Similarly, CSE is A is 1 group, CSE B is 1 group, CSE C is 1 group. In this way we discrete the things based on register number. So such grouping we are going to call it as so the task part of a data pre-processing, they are going to be data cleaning, data integration, data reduction, data visualization. So this entire topic, what is different primitives, how a claim is to take up. So let us have some errors. So you get a reading your home is not his error. So there we mentioned it is a human error. Assume the same person has come to your house to take a meter reading, and all of a sudden the battery went off, the battery drained. It is now machine is not functioning. So obviously you say instrumental error. So similarly, you brought the data to the internet and want to upload some file to the etc. So obviously the National Informatics Center, you need to connect it with internet. All of a sudden there is no data. So again, you say there is connection problem. Not so it's again a computer error. So in this, there will be a lot of reasons why data gets be incomplete. It can be a human mistake, machine, it can be a computer, it can be any type of logistic, any type of transmission where errors are going to occur, and those errors has to be rectified. That is why data is going to be dirty, or we are going to call it as impure. So how are these errors classified? The next way of putting this is how classify. One, we are going to say it is incomplete data. Incomplete data, and this incomplete data we are going to call it as a missing data. We are going to call it as missing data. So the definition here you can see it is lacking of attributes, lacking of certain attributes of interest, or containing only data. So I will just this again. So we were going to call it as data cleaning. In data cleaning, we were talking about incomplete data. So incomplete data, you have ID card have a field called as a blood group. So at the time of an admission, they will ask you what is your blood group. You don't know your blood group, so already that field will be empty. So putting this empty, we are going to call it as incomplete data. It is called as an incomplete data. So your blood group is there. So but still you are not aware of it, so you don't know the data, what data you want to put. So by mistake you can't put 0, you can't put A, you can't put etc. So if there is a blood requirement at that time, they will see your ID card and then they will arrange things to get A group. So at that time, if you put some wrong data, your group was and A blood they will insert, so it will be total headache, etc. So that is where consistent data is going to be so dangerous. So impure data has to be converted to a pure data, where the first we are going to call one as a data clean. So we talk about the first primitive called as incomplete. Here is an example, occupation, they have to write, so it is professor, teacher, etc., businessman, etc. So they don't want to give the occupation at that field, so they are going to leave it as empty. So leave it as empty, we are going to call that element as a missing data. Next one. The second word what we are going to bring to you here was, that is noisy data. So when we are going to call the word called as noisy data, so here is an example, salary. So our salary will be a positive number. Our salary will be a positive numeric. So I can't say it is wrong. I can't say minus 20 rupees 25 paise. Again, this is wrong. So these items we are going to call it as noisy. I'm going to write some 2,500. Yeah, it's okay. I'm going to write some 1,500. It is okay. So we are going so 1,525 paise. Yeah, it is okay. So we are going to put the things into numeric data. So if both of them are positive numbers, so salary fee should be noise free. So if we are going to have some errors such as noisy data, all be a numeric data type, but you are going to give minus 20 or FPE some character data, which is not going to be an acceptable or a valid data. So here we are going to get the word called as a noisy. This noisy data, it is going to push to the word called as an outlier. It is going to push to the word called as an outlier. So here is an example, salary, they have input minus 10. So it is minus 10, which is going to be wrong. You can put 10, it would have correct. So minus 10, it is going to lead to a error. So next thing, the third one was inconsistent data. So inconsistent data contains discrepancies in code or main. They are going to have some discrepancies in the output. So assume that you can see here the rating was as 1, 2, 3, but somebody is going to give it as ABC. So there is a match here. So from my side, I am going to do ABC. I am going to give 1, 2, and 3. I am using X, Y, Z. So obviously there is a mismatch at source, mismatch at destination. Similarly, assume your age, it was some 20 years. Now, on the other card, it is printed as 2022. So, obviously, your present age is 20 years. Your present age is 20 years. and the Aadhaar card is printed as 2020. Is a match. It is a mismatch. So what it is going to give? It is going to give a inconsistent because you are at 2020. So obviously maybe you have born in 2000, but the Aadhaar card is showing you are born in 2020. So this is you are going to say it is an operator error. It is going to be a human error. So due to some human error, due to some typing problem, due to some typing problem, due to some data entry problem. So there are a mismatch here. So this is what we are going to bring as a inconsistency. So inconsistency, assumption is one thing, resident is one thing. There is a huge mismatch between these two items. At that case, we are going to take the word here as an inconsistent. So we will ask. So